This is MAP4C, day 14, lesson 2.3. This is a bit of a strange lesson where we've got a very short 3-minute review here, easy, and then you'll be going and doing an investigation in class with partners. And if you need to get a hint, I'll give you a hint on that in this video. And then after you do the investigation, you come back and you can see the examples. The example 3 and example 4 are done with me. Example 1 and 2 with your partner. So let's just get into that. The goal today: solve problems involving the optimization of perimeters and areas. Optimization means finding the best perimeter, finding the best area, that sort of thing. And we've done this before in previous grades, but we're sort of smashing them all together and going fairly quickly through this material. So let's do it. 3 rectangles with an area of, I should use a ruler, but I'm not worrying about that. If the area is 60, I need the length and the width to multiply to get 60. So I just got to find some values that'll work. And, well, geez, there's one. 6 times 10 works. What else works? Oh, there's 5 and 12. That works. That gives me an area of 60. I could even, if I wanted to have a terrible one, terrible shape, and this isn't to scale, and again, I should use a ruler, but it could be 1 by 60, right? Any two numbers that multiply to get 60, right? That's what I want. I want length times width to be 60. And number 2, sketch 3 rectangles that have a perimeter of 60. Perimeter, remember, is 2 lengths and 2 widths to be 60. Or I could think of that: if 2 lengths and 2 widths is 60, then 1 length and 1 width is 30, right? So if I draw a rectangle, I need the length and the width to be equal to 30 when I add just the length and the width. And we could try a few here. You know, this could be 10 and this is 20, right? 10, 20, 10, 20, that's 60 all the way around. And lots and lots of possibilities here. 5 and 25, that works. The one that we're going to be after today, and we'll see this, is this one, a square. 15 by 15 is a square. And all of these have a perimeter of 60. All right, so again, the order of operations for today's stuff is a 3-minute review, the investigation, which, if needed, I'll give you a little bit of a introduction to here in a second, and then you come back with investigation with classmates in class, and then example 3 and 4 I'll do at the end of this video. So the investigation is here. The expectation is determined through investigation the optimal dimensions of a 2-dimensional shape given some constraint. Given some constraint is the idea of, you know, if I give you a certain number of patio stones, what's the best shape you could make the patio into? Again, this was with a partner, and it says you have 20 1-meter unbreakable sections of edging to enclose a rectangular garden. And in class, you'll be able to use either the whiteboards or toothpicks, or I'll show you could use the smart board here in a second. 21-meter unbreakable sections, and the idea is you're going to fill out this table. If the width is 1, what's the length and what's the area? Well, you might be able to figure that out without these, these tools, but let's just see. So there's my 20 toothpicks. What shape can I make out of them where the width is 1? I'm going to zoom out here just so I can. Okay, well, there's my width of 1. It's kind of like I got to start putting these toothpicks. Well, and you can almost see what's going to happen here. I've used 2 for the width, and then the rest is going to be put for the length, right? And of course, when you're doing it in class, you don't necessarily have to use the toothpicks, although this is a bit of fun. You could use, or at least one group could use, a smart board. or you could use grid paper, you know, and just draw the lines, or you could use the whiteboards, draw the lines. So here, what do we got? We got, that's a width of 1 and a length of 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice that this makes sense because we had 20 altogether, 1 there, 9 there, 1 and 9 makes a perimeter of 20, right? Halfway around is 10. So I'm going to go back to my table, put in the length of 9, and the area is 1 times 9 is 9 units squared, and then I'm going to put that on my grid once I'm done. And then you'll go ahead and you'll plot the data and you'll answer the questions and so on. For the next one, I'm going to zoom in for just a second. You have 24 one foot square and breakable ceramic tiles. So this is like the patio stand question. It says use tiles, paper squares, grid paper, or other methods. So this is the idea of now we've got these 24 blocks and we want to make a rectangular area. And we want to know, well, what some widths and lengths should be. Well, okay, well, certainly I could use this, put them together. And this isn't the first one necessarily. Probably you would guess that the first one might have a width of 1. And I'll let you figure out what the length would have to be there. But here I'm doing a width of 2. And let's just see what, you know, I'm using all these tiles. You probably fast forward the video. I don't know if anybody's even watching me doing this, because you can figure it out on your own, can't you? All right, well, what have we got? For the second one, we got a width of 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we had 24 to begin with. 2 times 12 is 24. That makes sense, doesn't it? That we had 24 tiles. So we're looking for, in this exercise, we're looking for numbers that go in here. I'm leaving some space. And then the perimeter, of course, is the distance around the outside. And that one is 28. And then we're going to try and find the minimum perimeter, plotting it on the table. Okay, so in a second, I'll show you my completed version. You can fill in the blanks, but you should try this with your partners first. You should pause the video. Okay, there's the first one. All of these numbers, notice, give you a perimeter of 20. Halfway around, these numbers add to 10, half the perimeter, and I get the maximum area. The maximum area happens when it's 5 by 5. Overleaf. We can try and find the best perimeter, and we get something that looks like this. Notice that it looks like if we keep messing around with the numbers, we try and make a square, these ones don't give you a square, right? You can't make it 5 by 4.8, even though that looks like it's around the best perimeter. So the smallest perimeter was 20 feet, which is 4 by 6 or 6 by 4. And notice how close to a square that is, and that's the best shape. So conclusions. When choosing a rectangle with a fixed perimeter, a square gives the maximum area. When choosing a rectangle with a fixed area, that's given the tiles, a square gives the minimum perimeter. So when we have these questions, we should be trying to make a square if we can. So here, 60 feet of fencing, what's the biggest rectangle you should enclose? Well, we're going to make a square, aren't we? Make a square. Draw a diagram, make a square. And so we don't know what the side length of the square is, but we know that it's going to be 60 feet all the way around the outside. Well, all the way around the outside, 60 feet is 4x's, and that's got to be equal to 60. Divide both sides by 4. I get 60 divided by 4 is 15. And so then 15 by 15. A 15 by 15 foot square gives the biggest area. And notice we didn't need a table there. When we're after the best shape, we know it should be a square. Example 4, we have 400 square feet of sod. So if when we've got sod, we can cut that into bits and pieces, right? It's not like patio stones. And that's the area, isn't it? Sod is like covering this backyard or whatever. And we don't know what the side length is, but we know it's got to be a square. So we know x times x, length times width, has got to be 400. What's the step? Square root 20 feet. And that's going to give me the lowest perimeter. And I know that it's a square. And 20 and 20 and 20 and 20. 80 square feet, or 80 feet, is a square. Done. There's some from the homework for you to try now.